Hi class. Today we're going to talk about radicals. We can think about radicals as being something that's opposite of an exponent. What I mean by that is when I say, for example, right here, what is the square root of 64? Basically, I'm asking what number times itself 2 times gives me 64. Well, that number is 8. 8 times 8 is 64, or 8 squared is 64. Same thing here, cube root. I'm asking because of the 3 here. I'm saying what number times itself 3 times gives you 27, and that is 3 because 3 cubed, 3 to the third power is 27. Anyway, there's tons of numbers that I have that we can calculate very easily in Desmos, but we're going to see how do we simplify radical expressions. Okay, so I'm going to teach you how to do that. Something to have in your mind or maybe even memorized is some perfect roots. These are all perfect roots right here. Not those numbers, these numbers that I have bolded here. Square root of 1. 1 is a perfect root because square root of 1 is 1. 4 is a perfect root because square root of 4 is 2 because 2 squared is 4. 3 squared is 9, so 9 is a perfect square because square root of 9 is 3, and then so on. So I would love for you guys to study these perfect squares. And we also have perfect cubes, meaning the cube root of 1 is 1 because 1 to the third power is 1. Cube root of 8 is 2 because 2 to the third power is 8, and so on. Okay, 3 cubed is 27, 4 cubed is 64. So the numbers I have bolded here are my perfect cubes. So if I were to ask you, what is the square root of 81? Well, square root of 81 is 9. That's a perfect square. So the answer to this is 9. And also Desmos does it pretty well for you too. To find square root, it's right here. Square root of, oh, you don't want 2 square roots, just 1 is enough. Square root of 81 is 9. There you go. The next example, what is the square root of 64? Square root of 64 here is 8 because 8 squared is 64, or I have a table, I can easily put it in Desmos and so on. I don't know why I have two 81s, but this is also 9, nothing changed there. This one is saying cube root of 261. So we have to think of a number that when I cube it, I get 216. I said 61, 216. So what number would that be? That number on my chart is 6. 6 cubed is 216. If you don't believe me, I'll put it in Desmos. See? Or if you want to find the cube root. Now cube root is a little bit harder to find in Desmos, but I do want to show you where to find it. To find cube root, you want to go to functions, and we're going to go all the way down to this nth root. Okay? And we have to type 3. And then you put 216, and then it tells you the answer is 6. So that's what that is. Okay, let's keep going. Cube root of 64 is 4. Cube root of negative 512. Now, negative 512 is right here. I have a positive version, but for cube roots, it is possible to get negative answers. So if you have negative 512, cube root of negative 512 is negative 8. Okay? All right, so now we are going to do some other things here. So I have a number on the outside right there. So I'm going to leave that alone for now. I'm going to bring that down actually, times the cube root of 4. Sorry, not the cube root, the square root of 4. Square root of 4 is 2. So now I do 16 times 2, which is 32. You can put this whole expression in Desmos, and it does it pretty good too. So I'll just go ahead and put that in there and show you that it will work. 32. Same thing with this one. I'll go ahead and put it in. QRT. Square root of 256 is, the square root of 256 is not 32, but 2 times the square root of 256 is 32, which means that this number right here must be 16, I believe. Let's check. Square root of 256 is 16. So that means that this is 2 times 16. So that is equal to 32. Okay. All right. So same thing here. I'm going to go ahead and bring down the negative 5 times square root of 121. That's 11. So negative 5 times 11 is negative 55. And then we do have some ways we can break down radical expressions. So right here, the radical does go to the numerator and the denominator. So essentially you're doing square root of 9, which is 3, over square root of 100, which is 10, and I'll leave it at that. Square root of 25 is 5. Square root of 49 is 7. That's my answer, 5 over 7. Cube root, so cube root of 1 is 1, and the cube root of 8 is 2, so 1/2. You can easily put all of those in the calculator as well. I'm not going to that. All right, now here is where it gets more interesting. So what about when I have radicals and they're not perfect squared? For example, if I look for 48 in my table, I have 49, but I don't have 48. So what do? Well, we're going to simplify it, meaning that we're going to take as much square roots, perfect squares out of here. So what that means is I'm going to look for multiples that are perfect squares here. So for example, I can do 48 divided by, let's see, the first perfect square I have here is 4. I'm going to see if 4 goes into it. And it does. So what that means is this can be written as square root of 4 times square root of 12. And then I can figure all that out. But I do think there are other square roots that are higher than, perfect squares that are higher than 4 that could probably go into 48. Let's see. So another square root I'm going to try is 9. Does 9 go into it? Nope, I got some fraction. Does 16 go into it? Look at that. 16 goes into it as well. So what that means is I'm not going to go ahead and use this, even though this works. I'm going to go ahead and use, one second. I'm going to go ahead and use 16 times 3. Whoops, hold on. I'm going to do square root of 16 times square root of 3. So square root of 16 times square root of 3 is 48, because 16 times 3 is 48. Let me show you. And now I can go ahead and simplify square root of 16. Square root of 16 is 4 times square root of 3. And this is what my answer is going to be. Okay? Yeah, so that's how you simplify. Basically, you're taking some numbers out of the radical by finding perfect squares. Okay, so let's try 72. I want to try to get some perfect squares out of it. Maybe I can start from the bottom this time. So I'll start with the number that's lower than 72. So I'll start with 64 to see. Obviously, it's not going to go into it, so that doesn't work at all. So let me try 49. Nope. Let me try 36, and 36 does go into it. What that means is it's going to be square root of 36 times square root of 2 gives you 72. These two are equivalent. So, and we know that square root of 36 is 6, so 6 square root of 2. That is how you simplify square roots. 63. So I'm going to start by putting 63 in my calculator, and I'm going to choose a number that's lower than 63 that is a perfect square. So 49, does it go into it? Obviously not. 36, nope. I'm going to try 25, it's not going to go into it. I think 16 might, nope. And then let me try 9. 9 goes into it. So I'm going to go ahead and say that this is square root of 9 times square root of 7. So square root of 9 is 3. So 3 square root of 7. I think that it would be really beneficial if you can truly just memorize some of the perfect squares and keep them in the back of your mind. All right, let's look at 90. So I'm going to start with 90 divided by, and I'm going to go here. I'm going to, well, 81, you know, it's not going to work. 64, nope. And then you have 49, nope. And then you're going to have 36, nope. Another perfect square, 25, no. 16, no. So now what? 9? Yep, 9 works. So what I'm going to do here is I'm going to go ahead and bring down the 2 that is on the outside times, and I'm going to rewrite square root of 90 as square root of 9 times square root of 10, because 9 times 10 is 90. I can simplify square root of 9 to say times 3, because square root of 9 is 3, and then square root of 10. And then we're going to clean this up by saying 2 times 3 is 6, square root of 10. A couple more examples here, guys. 175, I'll start with 144, I guess. No, it's not going to work, but you know. 121, no. 100's not going to work. 81 might work. Nope. 64 might work. No. 49, no. 36, no. 25, hopefully. Look at that, 25 worked. So I'm going to go ahead and rewrite this as, I'll bring down the 3 first. And I'm going to rewrite this as square root of 25, because 25 is a perfect square, times 7. So that square root of 25 is 5, and then there's nothing I can do with that 7. So 3 times 5 is 15, square root of 7. All right, square root of 10 here. Square root of 10, I cannot simplify that because there's not a perfect square underneath here. For example, I know that maybe I can rewrite 10 as square root of 2 times square root of 5, because 2 times 5 is 10. But 2 is not a perfect square, I should say, and 5 is not a perfect square. So this is going to end up being square root of 10, square root of 3 over 10. There's nothing I can do about that one. Okay, well, that was the lesson, the beginning lesson of this. It's going to get more interesting than this. So yeah, thanks guys.